Okay, so for question 14, you have information that this airplane is flying horizontally at speed of 150. So this is its U and it's moving horizontally. Automatically you know that it's going to be a horizontal projectile. Okay, horizontal projectile. And it also gives you that the elevation. Elevation means height. Okay, height is 2000 meter. Okay, from this information you can take out ux and uy. So 150 moving horizontally, therefore that's the value for ux. Automatically uy will become 0. And this 2000 here is height, therefore sy. Why is it negative? Because it mentioned that it drops a box. Okay, so when it drops the box falls down. So if you compare the initial and final position, the final position of the box is below the initial position, therefore the value is negative. Okay, so A, it asks you how much time for the box to reach the ground here. So T. Okay, so let's do SUVAT analysis. So S, okay, which component that we're going to use? Because we have ux, we have uy, and we have sy. So the most suitable is actually y, because we have uy and sy, but we don't have sx. Okay, that's how you determine which component you're going to use. Okay, so let's use uy for all. So sy we have negative 2000. So uy we have 0, vy we don't have information regarding that. Ay will always equal to 9.81, and the time is what we're going to find here. So the most suitable equation that we're going to choose is the one without v. Okay, so s equals to ut plus half a t squared. Okay, label everything. So if you label 0 times t, it becomes 0, but I'm still going to write the t. So half negative here and then t squared. Okay, this is negative 2000. So if you rearrange the equation, you will get time equals to 20.19 seconds. Okay. For part B, it asks how far does it travel horizontally? How far does it travel horizontally? So obviously, it asks you to find the horizontal distance, sx, or we call it range. So sx. So we are playing with the x component here. Okay, so let's do SUVAT analysis. SUVAT. So sx is what we're going to find. Ux we have 150. Vx will always equal to ux. Ax equals to 0, and the time is we obtain from part A, which is this one. So we have this. The equation suitable is the one with s, so omit this one. No. So the second and third one. But ax equals to 0, so if we put 0 here, so we cannot find s. Okay, so the equation that are suitable, is the third one. Okay, but this time we're going to use x component. Okay, so uxt 150 is 20.19 plus half. Ax is 0, so t is 20.19. Therefore we get x Sx equals to 3028.5 meter. Okay. Part C, it actually asks you to find velocity for its horizontal and vertical component when it strikes the ground, meaning V here, but it asks specifically for its horizontal and vertical component. So basically for part C, you need to find Vx and Vy. Okay, so simple. Vx is equals to Ux. Ux equals to U, which is 150 meter per second, given in the question already. So the problem is Vy here. So we need to do Suvat. So Y component, so Y, and Y. So Sy we have 2000 meter. Uy we have 0, Vy we want to find, Ay equals to 9.81 meter per second, and time is 20.19 second from part A that we found. Okay, so in order to find Vy, obviously we need the one with Vy in it, so we have the first and second one. So you may use both, you may use either two of this equation, but obviously I'm going to choose the easier one, which is V equals to Ut. Okay, so substitute Uy equals to 0, 1a, and then 20.19. So the answer is 193.06 meter per second. Okay, so that's the answer for this part, Vx and Vy. So for part D, actually it asks you to find the velocity of the box when it strikes the ground. So it actually want you to find V. So V, formula for V. Okay, formula for magnitude is this one. Substitute the value that we obtain in part C. I forgot to emphasize the negative here. Why is it negative? Because Vy is moving downward, so it has to be negative, the answer. Okay, so the answer is 248.45 per second. Then, if by any chance the question asks for the direction, use this one. Okay, must be Y over X. So direction for the velocity. Okay, that's all for question number 14. Thank you.